Hey folks, okay, well, this time I want to start looking at anonymous functions and building unnamed functions that we can use later. So we've already seen that we could go and create a bunch of code on the fly and store it in a variable and use eval or something like that to evaluate it later. What if we could build an entire function using conses and lists and whatnot and pass that off to a function to in turn go run? So if we're going to do something like this, since the function hasn't been declared we're not using defun to add it to our global namespace of functions, this function isn't going to have a name. It's just going to exist in a parameter or in a variable someplace. So we'll refer to them as anonymous functions, and that's what we want to take a look at today. All right. The word lambda is going to crop up a lot. Originally, way back when, it became fairly common in the sort of functional programming realm to talk about anonymous, or to use the lambda symbol to talk about functions. And so it became kind of natural when we start talking about anonymous functions just to use this lambda as a way to reference it. So in Lisp, the function that builds anonymous functions for you is called lambda. So the syntax to use a function, to write a function, is this lambda function. You specify the parameter list your newly created function is going to expect, and then whatever statements the function is going to execute. So let's say I want to create this anonymous function that takes two parameters, and if they're both numbers, then it multiplies them together and returns the result. So I call my lambda function. I pass it this parameter list. I tell it it's expecting x, and this newly created function is going to expect x and y as parameters. And what the function is going to do is say, okay, well, if x is a number and y is a number, then multiply x and y together and return the result. Right? So this is the syntax for creating a lambda function. Now, you could either pass this entire expression off to some other higher order function to run, or we could store this in a variable to be run later with a fun call or an eval or something along those lines. So there's lots of places where we're going to wind up using a lambda call. So here's an example. We'll go through. Yep, there's a mistake in that. There we go. Mistake gone. You saw nothing. Let's see. So here we have our function. Here we're calling our lambda function to go off and build an anonymous function. And once it's built and returned, that function is going to get stored in variable f. So our function x, all it's going to do is say, okay, if the x I was given is a number, return its negation. And if not, just return nil. Right? So the function will be stored in f, and we can try using it. We can run apply and say apply whatever's stored in f to 10. And again, remember that apply expects the parameters for f to be in a list. So here's the list of parameters, just the 10, and it should return a negative 10. Or I can say do a fun call on whatever's in f and negative 3, which should, again, negate that and return 3. Or do a map car where we're going to run f on each of the elements of a list, and we give it 10, negative 3, and 6, and hopefully it comes back with the list negative 10, 3, and negative 6. Right? So we can go through and, again, just play with this idea some. Say, all right, I want to create some variable f. I'll store my lambda function in it. What have I got open here? My if, my lambda, and my def var. So it thinks it's created a function f. If you want to take a look at what f actually is, you can look at this, and you can see in there the parameter list and the body of the function. This keyword at the beginning basically just identifies what kind of a function got created. And this is essentially just saying this was something that was built by the lambda function. And these three beasties here are environment variables that we'll ignore for now. So the meat of the function is whatever's here. So again, if we go through and try, apply whatever's in F to whatever's in my list here. Oops, what have I done? Oh, I see what I've done. Here, we'll, if we look up a little ways, I actually missed my space between my x and my negative here. So it thinks that's actually the name of a function. So let's just start this over. Good chance to see some error messages and what's going on. So if we do our def var, let's try this one more time. Let's try f, and we're running a lambda function. We're expecting a parameter x, and if x is a number, then we want to return the negation of x. And let's actually remember our white space this time. Close our if, close our lambda, close our def var, and take a look at what the body of f looks like, and we'll try running it. So let's run whatever's in f on whatever's in this list. Yay, it actually worked. And if we try it on something that's not a list, it's probably just going to return nil. Yay! Okay. And similarly, again, we can try fun call on this stuff, run whatever's in f on the value 200, or try a map car. Let's run whatever function is in f on a whole bunch of data values. Run it on 10, run it on foo, run it on -6, run it on 1.5. And again, it comes back and says, okay, well, negated the first one, the second one's not a number, negated the third one, negated the fourth one. So we've got the behavior that we more or less want. All right. So what we're going to do next is start getting creative with these lambda functions that we create. And we'll start building the functions in a way that we can pass parameters. So we'll have a function that writes our lambda function. We'll pass parameters to this construction function that tells it how to glue together the function that we want to build. So we can start having our code take parameters and build customized code based on those parameters is going to be the next idea. Now, just in terms of one quick and dirty way that you might see a lambda function used without getting into the fancy constructions and whatnot, suppose I've got a function that I'm going to apply to all the elements in a list, for instance, but this is the only place I'm ever going to use this function. I'm not going to use it anywhere else ever. I don't necessarily want to pollute my kind of global function namespace with this function that's only ever going to get used once in this one spot. So what I'll do is say, well, I'm going to run mapcar, and I'm going to give it the function to run on all the elements of the list, but I'm going to give it as a lambda function. Say, here's what I want you to do with it. You're basically just describing the sequence of operations you want done to each element and telling mapcar, okay, here's what to do. And you let mapcar go off and do it. Right? So that way you haven't polluted your global namespace, but you get the behavior that you want. All right. So that's our intro to higher order functions. We're going to make a lot of use of this in the next couple of weeks.